Hi all, Smackmaster C here, and this would be a review for molecular covalent compounds. Let's get started. First off, what are they? It's a combination of two or more atoms that are nonmetals. Not to be confused with the other video that's covering binary ionic compounds where it's a metal and a nonmetal. If that's what you're looking for, turn this video off and check out the other video. That's all I can say. So this is for nonmetals. What are nonmetals? Carbon, oxygen, phosphorus, nitrogen, chlorine, bromine, iodine, fluorine, and sulfur. All of these are nonmetals, and we can combine them in different ways. Okay? They are covalent because they're sharing their electrons, whereas the other one, the metal gives up its electron and the nonmetal takes it. But again, if you're there for that, turn off this video and get back to the other video. This is only for molecular covalent compounds. All right. So now we got the what's a nonmetal. How do we name them? We use Greek prefixes. So we have all these, and you should be familiar with them. Mono meaning one. Okay? Di meaning two. Well, wait, doesn't bi also mean two? You're right, but in chemistry we use di. Di meaning two. Tri meaning three. Tetra is four. Penta is 5. Think pentagon. Okay, hexagon is 6. Hepta is 7. Okay, and I'm missing one here. Oh my Lady Gaga, I can't believe I missed one. Here we go, it's octa. Octa means 8, like octopus. Okay, nona is 9, deca is 10. Yes, you have to know these. Okay? You have to know these prefixes. I am not giving those to you. Okay? I'm not. You're going to have to know these. Excuse me. Let's move on. Okay, we already talked about that. So, okay, how about some examples? Because I'm kind of confused. It's not a problem. Remember, if you're there for the binary ionic compound between a metal and a nonmetal, turn this video off. You gotta check out the other video that says binary ionic compounds. Okay? So, carbon monoxide. That's a great example of a molecular covalent compound. Okay? So what is carbon? Carbon is C, right? Monoxide tells us that there's an oxygen and it's going to be 1. So that would be CO. Dinitrogen tetroxide. Well, I have a nitrogen here. I know that's going to be an N. The oxide's going to be an O. Now, are we worried about balancing formulas here? No, we are not. Okay, this is different from the binary ionic compounds, a metal and a nonmetal. If you're looking for binary ionic compounds, turn the video off and get back to the other video, yo! Okay. So di means 2, tetra. You'd say, but wait, you told us about tetra, T-E-T-R-A. You're right, but you got an oxide in there, so it'll be tetroxide. So this is going to be N2O4. That is the correct formula for dinitrogen tetroxide. How about dihydrogen sulfide? Well, sulfide, yeah, that's an S, and there's only one. Okay, there's only one. It should be dihydrogen monosulfide, but dihydrogen meaning 2, so that would be an H2S. Dihydrogen sulfide. This stuff smells, that's what you find in rotten eggs and flatulence. Okay? Moving on, tetrasulfur decoxide. Woo, getting into some major numbers here. Player! All right, ballers, here we go. We got an oxide here, that's an oxygen. Dec, meaning 10 of these. Notice the difference between the number O and the letter 0. Here's tetrasulfur, I got a S here. Tetra meaning 4, so that means it has to be an S4O10. That's tetrasulfur decoxide right here. Okay? So, it's like a grilled cheese sandwich. The name grilled cheese sandwich tells you what's in the sandwich. That's no different. Tetrasulfur, 4 sulfurs. Decoxide, 10 oxygens. That's it. That's all that it is. Okay, let's look at H2O, shall we? Ooh, so now we got to come up with the name. I got 2 hydrogens and 1 oxygen, so I'm going to go with dihydrogen monoxide. See what I did there? Here's the di, meaning 2, mon, meaning 1, because I only have 1 oxygen. Here's the hydrogen, here's the oxygen, dihydrogen monoxide. And you know, Starbucks uses this. When it's thermally agitated, if it comes in contact with human skin, you'll burn. McDonald's uses dihydrogen monoxide in their floor cleaner and in their soft drinks. Ba-da-ba-ba, yuck! Not for me, thank you. All right, let's move on. PCl5. It's not an I, it's Cl. So it's a chlorine. So that means you have a phosphorus. Now, do we use the word mono for that first part? No. If we say phosphorus, that means there's 1 phosphorus there. If we say diphosphorus, then we know it's 2. Triphosphorus meaning 3. But you never have to use monophosphorus. That's kind of like extra, and it's like, it's just not worth the effort. So, with that, it's going to be phosphorus, pentachloride. Phosphorus pentachloride. Okay? Yeah, that's a juicy one, isn't it? Nice one. I guaranteed icebreaker at those high school parties. All right. Let's take a look at Cl2O. Now here, do we need to put the mon in front of the oxygen? Yep, we do. But you didn't put the mon in front of the P. Right, because that was the first part of the formula. Okay? So, this is going to be a dichloro. Oh, wait, dichloro? Yeah, won't it be dichloride? It's going to be dichloro. So it's going to be dichloro. So I got my 2 chlorines, and then I have a monoxide. So that's a dichloromonoxide right there. Yum. Okay? All right. How about IF7? It almost sounds like the impossible force. Or maybe it's the incredible force. Let's just get on with it. Okay, so here's iodine. So it's going to be iodine heptafluoride. Hepta meaning there's 7 of these fluoride atoms in there. The iodine, again, we're not using monoiodide because that's the first part. We did use the di in front of the chloro because there's 2 chlorines in the front. You'd say, well, okay, so iodine heptafluoride, dichloromonoxide. That's it. Okay, let's go. We got a couple more and then we're going to call it quits. Woo! All right, so I've got 4 phosphorus and 10 oxygens. I'm going to go with tetra. I'm going to go with tetra because that means 4. Okay, tetra phosphorus decoxide. Like that. So tetra phosphorus decoxide. Okay? Last one here. Ooh, that looks juicy. Let's see. We got 3 bromines, 8 oxygens. So I'm going to go with tribromine. You can say, but wait a second, wouldn't it be tribromide? No, because it's not. The only way it becomes an ide is if it's on the other end. The end that it picks up an electron. This is not picking up an electron here. So tribromide oxide. So tribromine or tribromine octoxide. Okay? Man, juicy. Okay, let's see how much time I have here. Do you guys want me to wrap this up? Well, you can fast forward this, okay? But I went ahead and I went through. I started out with this, okay? And we talked about what are molecular covalent compounds. These are the ones that have nonmetals in them, and you have to use the Greek prefixes. Mono, di, tri, tetra, penta, those things. Okay? There are no metals here. If you have a metal with a non-metal, turn off the video for the 50th time and go and watch the other video that deals with it. Okay? So we talked about what are non-metals, and you've seen those here. Okay? How do we name all our prefixes? Okay? And then we looked at specific examples where you will be given the name of a formula and you have to write out the formula correctly. Okay? And again, if you look at these, you should be good to go. Alright? And we talked about dihydrogen monoxide. We talked about phosphorus pentachloride, dichloromonoxide, iodine heptafluoride, and then tetraphosphorus decoxide, and last but not least, tribromine octoxide. Ooh. Okay, I think we're done. This is definitely a shorter video compared to the other one because there were other things like oxidation numbers and all that, and why do we need to balance it? It becomes 0. So we're good for that. I think we're done here. Okay? Wait, what about the non-metal?